Okay, today we're going to talk about area. Polar area. Okay, so the length of an arc in a circle is given by r times theta when theta is in radians. That is something that you learned when you first learned about radians in geometry. Okay. For a very small theta, you can imagine a triangle, right? Where this is theta. Here's our radius. Okay. And our arc length would be r d theta because we have a itty bitty change in theta. Okay. Now, area of this triangle, 1/2 base times height. Area of any triangle, 1/2 base times height. So 1/2 base times height would give us 1/2 r times r d theta. Base is r d theta. Height is r. So 1/2 r squared d theta. Do you see where this is going? If we want the area of inside of the polar curve, we're going to take all of these itty bitty triangles and do what with it? Add them together. Where's this going? It is going towards integration.
Yeah, it is.
Are you ready?
Yeah. Hit us with it.
A nice addition. Okay. Are you ready? Okay. So we can use this to find the area inside the polar curve. So here's our polar curve. We're going to get an infinite number of these and add them together. The area inside a polar curve is the integral from alpha to beta of 1/2 r squared d theta. What did you say? Well, fraternities and sororities do use Greek letters. They don't think they're of Greek origin or Greek descent.
The swimming flat is called the swimming capigoggles.
What? Swim a what?
Swimming capigoggles?
Very nice. All right, so we're going to do a couple examples. R, U, ready?
Yes. Are you ready to be beat from the test?
What's that?
Yeah.
Oh, that's so done.
Yeah, we know that one. We know which one. Yeah.
Peter, Nick, you ready?
I know that one.
Are you done writing?
No.
You're not? What do you need to write?
It's drawing that weird circle.
Are you writing from your phone?
The last line.
Yeah.
I got it.
All you need is 1/2 R squared equal.
Yeah, I got that down now.
And then put them in your interval.
Okay. Find the area enclosed by this guy. Now we know it's a cardioid. Basically 2 plus 2 cosine theta, right? Here's where our chapter of integration techniques is going to come back to help us. Okay. You can do this one of two ways. You can find half of it and double it, or you can find it from start to end. What would you like to do? Okay, so half would be from, so we have 1/2 from 0 to pi. Oh, I guess we should hold on, shouldn't we? If we plug in 0, where are we?
4.
So from 0 to pi, we'd be finding this half. You want to make sure 0 to pi is going to work, because you don't want to be finding like this half, right? Okay, you want to find the symmetrical half of 2 plus 2 cosine theta squared d theta, and then we are going to double it. Yep. But you know what?
Why don't we just keep off our one?
Well, I'm going to leave it how they have it. That 2 times 1/2, what's going to happen? It's going to cancel, which is why it's kind of nice to do half of it and then double it, because then those go away. Now, 2 squared is?
4.
So I'm going to throw that out in front. And then we have 1 plus 2 cosine theta plus cosine squared theta d theta. Can we take the antiderivative of cosine squared? No. The equivalent of cosine squared is good. 1/2 plus 1/2 cosine of 2 theta. Okay. Oh, we don't need that. Okay. Antiderivative of 1. Theta. Antiderivative of 2 cosine theta. Antiderivative of 1/2. Antiderivative of 1/2 cosine of 2 theta. Okay, so I'm going to combine theta and theta over 2 to be 3/2 theta. You okay with that? Okay, so we have 4 times 3 pi over 2 plus 2 times the sine of pi plus 1/4 times the sine of pi minus 4 times 0 plus 2 times the sine of 0 plus 1/4 times the sine of 0. A whole lot of nothings. What's our answer?
That's 6 pi.
I got 6 pi. Where did your 8 come from? The rest are zeros. Right?
Whoops.
6 pi. That's the area. What do you think?
Alright, so far. That's the first one. How many examples are there?
2 area examples.
Oh, no.
1 petal.
Yes, thank you.
Good.
Oh, area.
I forgot about these already.
Uh-oh.
There. You all are my most entertaining class of the day, and I appreciate having you 7th hour. You complete my day with a bang. Okay. In order to find the area of 1 petal, what do we need to know?
Area of
No.
Zero.
Zeros. We need to know where the petals start and end.
Like 4 days ago.
Okay. How many zeros are there?
3.
3. So the first 3 places cosine of 0 is pi over 2, 3 pi over 2, and 5 pi over 2. So our zeros are at pi over 6, pi over 2, and 5 pi over 6. Okay? It does not matter which 2 you choose as long as they are consecutive.
Right. 5 or 6, 5 or 2.
Is this just for a boundary then?
Yeah.
Could you also go like, let's say you went 0 to pi over 6, then multiply it by 2.
Could you do that?
Yes.
Yes. Yes, you could. It could be nicer.
Well,
It's probably going to be,
it's going to look nicer this way.
yeah. Yeah.
If you did 0 to...
No, wait.
You don't want to do that. You want to go counterclockwise.
What if you do like 0 and halfway through the other one?
This is the... What if you did 0 to pi over 2?
Yeah. No, what?
0 to...
We're talking about 1 petal, buddy. So he's saying 0 to pi over 6 and doubling that area. Because what happens, and I probably should be a little bit better. So this is 0, right? And so starting at 0, we are calculating area. So area at 0, and then a little bit more than 0, and then a little bit more than 0, and so it's like tracing all like that. And then it starts tracing here.
And what if you went to like halfway through that petal? Would that work?
I think it's before
Probably,
Where are
yeah.
you at right now? Can you do that right there?
That would be more than what we want.
That'd be petal.
that. If you wanted to fill the whole thing.
Okay. But do you see how I'm drawing it though? How I'm basically like drawing the radii until it's like all filled in. Okay, Alex?
So I understand like how to solve for the zeros. I just prefer to like draw it from, like I don't know what the zeros actually mean.
That just means where we touch the pole. It's really not going to help you draw the curve. Okay? What's going to help you draw the curve is if you plug in 0 to this, we get 3. And so we have a petal there, And since we have 3 petals, we know that they are every 120 degrees apart.
This one goes kind of backwards, right?
Yeah.
Okay. So it goes like, we start at the 3 and we go like down to the 3.
Oh, I thought you started in the middle, so I was confused.
When it's a sine curve, you would. Does that help? Okay. When we get to a sine one and you're confused about what it looks like, we can talk about how you get that. Okay?
So pi over 6 would really be like 0 to pi over 6 would be like here to here.
0 to pi over 6
Oh, no, that doesn't-
would be from here to here.
Okay. I guess that makes sense.
All right, so I'm going to change this to 9/2 integral of pi over 6 to pi over 2 of cosine squared of 3 theta. How are we going to rewrite that?
No. It's just,
It's 1/2 plus 1/2 cosine of 6 theta.
Good. So, we have 9/2 times theta over 2 plus 1/12 sine of 6 theta. What's the sine of 3 pi? That'd be 0, right?
So it's 9.
So we have 9 pi over 8 minus 9 pi over 24. Which is? 3 pi over 4.
Is it always going to cancel out?
Well, if you play your cards right, like, we picked nice values, right?
Yeah.
Like pi over 2 is a nice thing to plug in. 0 is a nice thing to plug in. I wouldn't say it's always going to cancel out. All right. When we talked about arc lengths for a parametric, what was it?
Square root of something.
1 plus.
Okay. That's correct. But not for parametric. That was for non-parametric. Yep. The x dt squared plus dy dt squared, right? Well, if x equals r cosine theta and y equals r sine theta, then we actually get this when we plug it in. Why is that? We would get r squared cosine squared plus r squared sine squared. Whoa, that's not good. Okay, we'd get a big mess. That would simplify to here. Okay, We can go through it if you want to. But the arc length would be this. Huh? What did you say?
I was just saying,
You were singing? Is it Travis Tritt? Because that's all my sixth hour can sing to sing.
Travis Trick.
Tritt. Travis
I
Tritt.
haven't heard of that. Never heard of that.
Please don't.
What about the ICP? The Insane Clown Posse. Learned a bit about them recently, the last 3 days of English.
Are you ready?
Yeah.
Nope.
Yeah. That's another chicken. You can't do it though. They will get in trouble for this. But it's such a classic. Come on. What's harassment? Which obviously you know how we didn't get it. It's great. It'd be a lot.
Thank you.
You say for the tower? That's
Six.
Robert and
Caden.
Solely?
Yeah. Okay, Peter and Nikki, let me know when you're good.
I don't need your rocking chair. Here's a quarter. I'll have to look at this guy. I don't know. Take a long way.
Enjoy driving on clear roads while you can today.
Won't be doing any driving tomorrow.
If we don't have school, I really would encourage you to stay home and not drive. You're not very experienced drivers anyway, so if it's icy out, just don't.
Can we go for a run?
Isn't that how we gain experience?
I suppose. All right, last example. We're going to do this example and then call it a day.
Let's go.
Interview for what? Oh, you will be interviewing. Oh, wait, for your lifeguard. Oh, then you will interview with my mother-in-law, Cheryl. All right, so what is r prime? What is the derivative of r with respect to theta?
Theta plus m minus
I'll let you-
Oh.
how about just solar person?
Why am I finding that?
You need it.
Yes. Okay. So in our integral, we are going to have r squared plus r prime squared theta. Now, we can go from 0 to 2 pi, or in this case, we could go from like 0.
Let's go the whole way.
What?
Do that.
That's right.
Can we go all the way around?
This begins where? It begins at 1? That would not be a good place to start then, would it?
You can get,
Oh, you go that way? Why can't we go all the
You
way
have to be
around?
above the x-axis.
Is that not legal?
Huh?
It's not legal to go all the way around.
Well, could we do pi over 2? The 3 pi over 2?
It doesn't above the x-axis.
Oh, it says above. Oh, that's why. I was like, why do you keep telling me that? So 0 to
Whatever equals -1, so. Times that one. That makes sense.
You know this one.
Now, I'm going to make a suggestion because I know what's going to happen. We're going to use, we're going to do half of it in double. Because I want to stay within just one quadrant. And I'll explain why when we get there. Now, this is going to be pretty intense. More intense than anything I would expect you to do by hand.
I have like 2 lines.
Oh, wait, it's not like that.
I have
Pencil.
actually 4 if I want to go another.
So here we get 1
I got 1.
plus 2 sine theta plus sine squared theta plus cosine squared theta d theta. What happens? Sine squared plus cosine squared is 1. Technically, we can factor out a radical too. So then we can only worry about radical 1 plus sine theta.
Sure.
You see how I did that?
Yeah.
Okay. Here's where it gets exciting. Are you ready?
Yeah.
Yeah.
Yeah. We'll see.
Do you have any idea how to integrate that?
Oh.
Ew.
Okay, let's talk about why I'm doing that.
So you can do it?
Yes.
What happened to our
However, the plus isn't going to help. Sorry. We're going to do conjugate. Why do I want conjugate?
So something fancy.
We have the square root of 1 minus sine squared over the square root of 1 minus sine. What is 1 minus sine squared? Cosine squared. And as long as we are from 0 to pi over 2, the square root of cosine squared is cosine. In the second quadrant, cosine is negative. So the square root of cosine squared would not be the same as cosine from pi over 2 to pi.
So would that mean we have to do 2 separate things?
Yeah, and we don't want to do that. The square root of cosine squared in the second quadrant would be negative cosine. Yeah. So, Mr. Warner, Mr. Isaac Warner, sorry, you told me to play that. What did you say we would have to do? We would have to do some u substitution where u is 1 minus sine theta.
Yeah.
Du is negative cosine theta.
Negative do is
I'm going to go ahead and change the limits of integration because I just am kind of tired of calculating at this point. Okay? So we get u to the positive 1/2 times 2. So I'm going to call this negative 4 radical 2 u to the 1/2 from 1 to 0. So we get 0 minus negative 4 radical 2. The arc length is 4 radical 2. We made it. What's your question?
I have a
Is it
question.
1 to 0 or 0?
It's 1 to 0 because when we plug in 0, 1 minus the sign of 0 is 1, so it has to go there. And when we plug in pi over 2, 1 minus the sign of pi over 2 is 0, so it has to go there. Do you understand what I'm saying? Okay. So your homework tonight is your book assignment.